Hello guys, welcome back. Let's go ahead and take a look at the concept of ether channels, also known as port channels, in this particular video. We're going to take a look at we'll take an overview of what an ether channel is. We'll take a look at the advantages of an ether channel, what are the different ways of setting it up, and then the two protocols that allow us to negotiate an ether channel, which are the Cisco proprietary PAgP and the LACPE protocol, which is the industry standard protocol for doing it. But before we get into that, let's understand the requirement. Why do I need an ether channel? We went through the STP video or lecture. When you looked at it, you saw that anytime you have a dual link between two switches, forget about the overall picture, but just between the two switches, switch 1 and switch 2, do you remember that broadcast storm issue that I had? If I send a broadcast from PC1, it would have gotten forwarded over gig 00 to the other device. It would have been received on PC2 as a broadcast. At the same time, because the broadcast came into the switch, if both ports were up, switch 1 would also forward the same broadcast over gig 01 to the same device. And this guy now would have received two broadcasts for the same one. Not only that, it doesn't end over there. The blue broadcast would have made it back onto the switch over the other port. It doesn't go back on the port it came in from, but it would go to the other trunk port. At the same time, the broadcast that came in from gig 01 would tunnel back over here to switch 1, and that would continue on, and that would cause an endless loop. So what STP would do is they would automatically detect that loop based on the BPDUs and block one of the ports, which is good to avoid the loop. But at the same time, now let's say these were two 1 gig ports, which would have given me 2 gigs of uplink between switch 1 and switch 2, which is something that is required because you have multiple PCs that maybe want to communicate to multiple devices on the other switch, and you might need more bandwidth between the two switches. But rather than having 2 gigs, now I'm limited to 1. Even if I had 4 links connecting switch 1 to switch 2, STP would only allow forwarding of 1 port, and that would only give me 1 gigabits per second of speed, provided that these links were 1 GB per second. All right. So over here, I have 3 different switches that have dual links, and all of those, only one of them will be used. And that's where the concept of ether channels, which is also known as port channels. The same thing, whether you use the keyword or the terminology of port channel or ether channel. It is basically the same thing. In the Cisco world, the port channel is called an ether channel, but in the open standard world, it's called a port channel. What is a port channel? It allows you the ability to aggregate the two interfaces as if they're one single logical interface. All right, by doing that, it will present those two physical interfaces as a single logical interface to STP. So STP will not see it as two interfaces, it'll see it as one. So when the broadcast came in from these PCs, PC1 and let's say PC2, it would forward it on this port to the other side, on both the ports simultaneously. How about the loop? Well, ether channel or port channel has a built-in capability where it looks at the two member ports. So when a frame comes in from one of the member ports, not based on the switch, based on the ether channel capability, it sees if a frame came in from one of the member ports, it is not going to send the same frame back on another port that belongs to the same ether channel. So what it does is basically the ether channel makes sure that the frame is not forwarded over another port that is a member of the same ether channel. So ether channel makes sure that the frame does not cycle back to the original switch. That allows me the ability to bundle these interfaces to each other as if they're a single logical interface, and hence I get redundancy. So in case of one going down, redundancy, we get redundancy, and we also get load balancing in the sense that both interfaces are used. So one flow will go on one, the other flow will go on the other channel. All right. So that's the advantage that you gain with having EtherChannels between the two switches. All right. So let's go ahead and take a look at the overview now that you have a basic understanding of what an EtherChannel is. Yeah, basically, this is the same thing that I just mentioned in my lecture. In order to provide redundancy between two switches, you connect two or more links between them. This leads to issues like broadcast home that have been discussed. Remember, we discussed that in the STP video. In order to prevent that, STP will only allow a single forwarding port between two switches. Although you have redundant links between the three switches, which is switch 1, 2, and 3 over here, only one of the links will be forwarding. So this is where the EtherChannel or port channel solves the issue. All right. Initially, EtherChannel was introduced by Cisco as a switch-to-switch technique so that you could aggregate, bundle multiple Ethernet interfaces into a single logical channel. All right. Now, depends on this, the model of the switch. The minimum number of ports that you should have in an EtherChannel is 2. Some of them support up to 8 ports in an EtherChannel. Some of them even go up to 16 in an EtherChannel, depending on the model of the switch that you have. All right. So you can have up to 16 ports in an EtherChannel, which is an overkill because that doesn't leave you too many ports available for the end devices on a normal switch. But sometimes on a aggregated switch, you do have the capability of doing that. All right. So with an EtherChannel, you can have all those 4 ports, giving you the capability of load balancing over the ports. All right. So that's where you're aggregating the links. So if you have two 10G links between the two switches, now all of a sudden you get 20G between the uplinks between switch 1 and switch 2. All right. And those are also listed in your advantages of EtherChannel in the next slide. So bandwidth aggregation and load balancing, I just talked about it. So over here, rather than having 1G and 1G, I would get 2 gigabits per second. If I had 10 and 10, I would get 20. All right. That's the first advantage that you get. So once you aggregate the bandwidth, you can do load balancing. Both ports are forwarding. Just in case one of the port goes down. So let's say you have 2 ports connecting the 2 switches to each other. Just in case one goes down, the EtherChannel is still up because one of the links is up. If all links go down, then you don't have a choice. But at least in case of one link going down, yeah, you don't have 2 links worth of speed, but at least your redundancy is in there still. The other advantage that you gain is the configuration part of it. When you do configure the EtherChannel, most of the commands that you do is done in a logical interface. So this also brings a bit of the configuration over here. When I want to link up 2 interfaces to be part of an EtherChannel, what I do is I go into the physical interface, and generally I would do the range command for that, gig0/0-1. So I'm going to do these commands on both 00 and 01. I'm going to say channel group, pick a number which is locally significant. Let's say I pick number 10 over here. Mode on. I'm turning this EtherChannel on. I don't need to do a no shot on the physical interfaces in the switch, but still, just to be on the safe side, you do that just in case somebody had shut the ports down. Now the 2 interfaces, gig00 and gig01, are bundled as a single port channel, which is, or EtherChannel, which is port channel 10. It automatically will create a logical interface for you, and this interface is called a port channel interface. So now let's say you wanted to create a trunk between the 2 switches. You don't do it under the physical interface, you do it under the port channel interface. So for example, you would say switch port trunk encapsulation .1q switch port mode trunk. All right. So this allows you the ability, whatever you do on the port channel will automatically get applied to all the member ports. That's what I'm talking about. You have the ability to configure the port channel. It automatically applies it to the member ports. All right. That's the other advantage that you have with doing the EtherChannel, the configuration part of it. Not that big of a deal, but it's still there. Now, how do I set it up? There are 3 different ways of setting up an EtherChannel. or a port channel, whatever you feel comfortable calling it. Personally, I would call it a port channel because it's more of an industry terminology rather than EtherChannel, which is more used in the Cisco world. So let's say you have switch 1 connecting to switch 2. One of the things that you can do is you can, if you know that these two ports, let's say gig 0/0, gig 0/1, doesn't have to be the same ports. Purposely, I'm going to put different ports over here. One's 0/2 and 0/3. They don't have to be the same ports. Now I'm connecting switch 1 and switch 2 over these two ports, and I want to configure a port channel over here between switch 1 and switch 2. One of the ways you can do it is you go under the interface gig 00 and gig 01 and say, hey, listen, I want these two ports to be part of a port channel. Manually. So I do the same thing on the other side. If I do it manually on one side, I need to set the same thing manually over here. Over on switch 1, I'll say gig 0/0 and 1 are part of a EtherChannel. Over here, I'll say gig 0/2 and 3 are part of the EtherChannel manually. What do I mean by manually? They don't talk to the other side and say, hey, listen, as long as this port is up on the other side, I am going to consider the port channel to be up. So there's no negotiation with the other side whether the device, the port, is actually a member of the same port channel or not. So there's no negotiation. I manually specify that these two ports are a port channel with the other switch. All right. In case you do some type of configuration where you go in and I don't bring the port down, but you say, oh, I don't want gig 03 to be a port channel. I accidentally specify gig 04 to be a port channel. Now that's going to be an issue with manual. Why? This guy thinks gig 01, which is connecting to 03, is a port channel, but I haven't configured that over here. But from his perspective, that port channel is up. So he's going to start sending traffic over that port thinking it's part of the port channel. Okay? Whereas this port over here will be thinking that this is connected to this switch, or it might not even be connected to this switch, it might be connecting somewhere else. All right? So when you do that, if you unbundle a port from a port channel, the other guy is not aware of it, and he keeps on sending traffic over that port, which can lead to black holing. So that's why generally it is recommended stay away from the manual configuration, although you can do it, because if you at any given time unconfigure a port from a port channel, the peer switch would not be aware of it. That's one way of doing it. Let me bring it up for you guys so you guys can see it. Actually, let me just finish the lecture portion and I will go back to the slides and go through each one of them and the characteristics. The other way of doing it, rather than doing it manually, which is not recommended, as I said, the other way to do it, what Cisco did initially was use a protocol called the Port Aggregation Protocol, PAgP. What it does is it actually communicates to the other side and says, hey, listen, when this port comes up, let's say I've configured gig 0/1 and gig 0/2, which is connected to gig 0/, let's say 0 and 3. I did it on purpose so that they're not the same ports. It could be the same port, could be different ports. It's irrelevant. It's locally significant. Now, when I'm running PAgP as my protocol, what happens is as soon as I bring the port channel up, it starts communicating to the other switch and says, hey, listen, are you part of a port channel? And he sends the same frame over here. Are you part of the port channel? As long as they come back and say, yeah, I'm part of a port channel, they negotiate that these two links are part of a port channel, they don't start sending the traffic to each other. So there's an actual communication that takes place between the two ports in this active negotiating protocol, a dynamic protocol that will actually negotiate the port channel, which is PAgP. This is a Cisco proprietary protocol. Cisco came up with it. They used it on their switches. Now, in this case, if I unchannel this particular link, guess what? The other guy, because of PAgP, will be aware of it. He will take that port out of the port channel. So you'll have a single port channel on both sides. Although my configuration over here shows it, but it's going to bring that port down and says, hey, listen, this port on the other side is saying I'm not a port channel. So bring it down. All right. So initially it was PAgP, which was the Cisco proprietary version of it. Then IEEE came in and standardized it, and that protocol was called the Link Aggregation control protocol, LACP. Same concept. It will negotiate between the two different switches on the ports. If the ports are configured properly, they will form the ether channel. If they're not, it will not form the ether channel. You might have one port form it, the other one not, because they're not physically connected properly, but there is an actual negotiation that takes place between the two switches. Now, just like ISL and .1Q we talked about earlier on as the trunking protocols, same thing over here. This one is almost out of the door. A lot of the newer switches from Cisco don't even support it. This is the standard that everybody uses in the industry, including Cisco. So most of the Cisco switches, although we don't cover that in this particular class, we have a series of switches from Cisco called the Nexus series. Nexus does not even support the PAgP protocol. It only supports LACP as the port channel protocol communicating between the two devices. It supports manual or LACP, just to give you a heads up of that. Now, let's go ahead and take a look at the setup. The slides, basically what I just talked about. You can configure the ether channels by manually configuring the member ports on both sides. You could use dynamic protocols to do that. What are the dynamic protocols or negotiation protocols that you have for that? We talked about it, the link aggregation control protocol or the port aggregation protocol. This is the standard protocol, IEEE standard. This one is a Cisco proprietary protocol. All right. As I said, this is almost out of the door right now. It's not being used as much. Now, a little bit about each one of those two protocols in a little bit more detail in the next slide. Let's talk about LACP first. LACP again helps the ether channel link by detecting the configuration on each side. So it goes to the other side and says, hey, listen, are you part of a ether channel or not? If it is, it says, okay, good. I'll set up the ether channel. Now, LACP, when you configure it, there's two different ways of doing it. One way is telling the switch when you come up and the ether channel has been configured, it will try to actually negotiate the ether channel. So it actively looks for what? A peer on the other side using LACP. This mode is called active. In this, the port actually tries to go to the other port and says what? I misspelled this. Let's fix this over here. Negotiations. So in this particular one, when I set the mode of that port to be active, it will actually try to negotiate a port channel with the other side. Passive will respond. Passive will not initiate. So if you have two switches that want to set up a port channel with each other, at least one of them needs to initiate the connection. At least one of them has to be active. The other guy can be passive, so it will respond. It won't initiate the traffic, but as long as one of them initiates it, I will respond back to the packet trying to negotiate an ether channel. Say, okay, yeah, I'm a part of an ether channel. What happens if I set both of them to be passive? This is a problem because it's like two shy people in the room. No one will initiate the conversation. Because no one initiates a conversation, the ether channel does not come up. So you cannot have both sides set up as passive. At least one of them has to be set as active. As long as you set one as the active one, the other one will respond as long as it's as passive. But has to be LACP. So in order to do LACP, you have two options for the mode. The mode is either going to be what? Active or passive. When you set the mode to active or passive, you automatically know that you're setting up LACP as the protocol. You cannot have active on one side and on or manual on the other side. If it's LACP on one side, it has to be LACP on the other side as well. Well, PAgP works the exact same way. It's just a Cisco proprietary way of doing it, but it's basically got the same concept. So PAgP will also help you create the ether channel by detecting the configuration on the other side. It'll send the negotiation packets. Now, who's going to send it? What the active did in the LACP protocol, the same exact configuration or same exact, behavior is done by the mode called desirable in PAgP. So active equates to desirable. Desirable is the one that will actually try to negotiate the Ether channel. The other side, if it's set to auto, which is misleading, auto generally means that it will automatically do it, but auto will only respond back. Just like the passive only would respond back to the setting up of an Ether channel, auto does the same thing. So auto, if you have auto on both sides, the Ether channel will not form. All right, it has to be, at least one side has to be desirable, just like in LACP, one side had to be active. So auto doesn't work, desirable auto would work, or desirable would work. In LACP, so these are the combinations that can work. Let's write them down for you guys. In case I'm using static, which is the manual mechanism, both sides are required to have on and on. This is one working setup. If I'm doing LACP, there are two combinations that will work. Either active will work, both sides are active, or one is active, the other one is, one side is active, the other one is passive. This is also okay. In case of PAgP, which I really don't care about too much because it's almost out of the way, the commands are desirable, auto, or desirable. Actually, I should say desirable first. So just like I did active first, so desirable, or desirable, auto. All right, 1, 2, and 3 different ways of setting up an Ether channel. In this particular video series, we're just going to take a look at static and LACP. This one, as I said, is not that important. It's almost on its way. So in the next video, we're going to take a look at how to set these 4 channels up. We'll do static in the next video and LACP in the following video after that. Hope you guys enjoyed it. Thanks for joining me. See you guys in the next video.